you are able to tackle all those formulas in solving a particular question, you can solve any question in other subjects as well. And I'll be sharing a PDF as a solution for these questions. Practice as many questions as possible, students. You can crack the boards, like you can get 100% in boards. Hello everyone, welcome to ATP. I am Pawan. I am your maths faculty here. Today we are going to discuss trigonometry, a very important chapter. Many students feel it is a little difficult when you solve proving questions in trigonometry. But when you know the particular approach, or when you study the trigonometry in a systematic way, you will feel the proving questions are very easy to solve. So going to the trigonometry, let's see the summary of the chapter, and we will see some 10 questions, 10 proving questions. By solving these questions, you will feel that you can solve any question. Okay, students, let's move to the summary of the trigonometry first. So first, we know in trigonometry there are trigonometric ratios, right? So in a right angle triangle, the side opposite to the right angle, let's suppose this one is called hypotenuse. Let's suppose this angle theta, the angle here. So now the side opposite to this angle is a perpendicular side, and the side adjacent to it is called the adjacent side. Okay, so there are 6 trigonometric ratios which you know: sin theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. So each trigonometric ratio, sin theta, you can say it is opposite by hypotenuse or perpendicular by hypotenuse. Cos theta, you can say adjacent by hypotenuse. Tan theta, you can say opposite by adjacent. Cosecant theta, you can say hypotenuse by perpendicular or hypotenuse by opposite. Secant theta, you can say hypotenuse by adjacent. And cot theta, you can say adjacent by opposite or adjacent by perpendicular. So very easy, right, students? Let's go to the next one. Relation between the trigonometric ratios. You can see from here, the cosecant theta is 1 by sin theta, and secant theta is 1 by cos theta, and cot theta is 1 by tan theta. Students, these are very important ratios. If you know this, even very difficult proving questions you can do in fingertips. It's very easy when you remember these relations. Let's go to the next one. So tan theta is equal to sin theta by cos theta, and cot theta is cos theta by sin theta, and tan theta into cot theta, we got it 1. So these are called quotient relations. Okay, next important one, they are trigonometric identities or square relations, we call it. So sin square theta plus cos square theta equal to 1, and 1 plus tan square theta equal to secant square theta, and 1 plus cot square theta is equal to cosecant square theta. Okay, students, keep this all the formulas in your head. So once you know this, once you're very confident which ratio to be used, which trigonometric ratio to apply in different questions, as you see from the question 1 to question 10, you can see that, oh, I can solve any question easily. See, this trigonometry is very important. Why? See, here we have a lot of formulas in trigonometry. And if you are able to tackle all those formulas in solving a particular question, you can solve any question in other subjects as well. You can remember many things and particularly use those concepts in those subjects, you can say. So let's go to the important questions. So we'll solve 10 important questions. At the end, I'll give you some questions for you to solve, and I will share the solutions at the end as well. Let's go to the question number 1. Prove that sin A divided by 1 plus cos A plus 1 plus cos A divided by sin A is equal to 2 cosecant A. Okay, students, see, you have 2 terms in the left hand side, but you have only 1 term in the right hand side. Okay, students, the trigonometry proving questions, you have to adjust yourself to get the RHS. Or if you start with RHS, you have to make sure that how to get the LHS. This is the way. It's not that you want to get some other different result. Proving questions, you try to use all the formulas to get the desired output, right? So let's see how we do that one. First one, take the LHS, students. So sin A by 1 plus cos A plus 1 plus cos A divided by sin A. Now we have 2 fractions. Generally what we do, we take the LCM of the fraction and multiply, right? So let's see this one. So the first, you can see the sine will be multiplied with the sine, and 1 plus cos A will be multiplied with 1 plus cos A. So it becomes sin square A plus 1 plus cos A whole square divided by 1 plus cos A into sin A. Now just expand 1 plus cos A whole square. So we get sin square A plus 1 plus cos square A plus 2 cos A divided by 1 plus cos A into sin A. You know, sin square theta plus cos square theta is how much? It's 1, right? But the trigonometric identity is the first identity. So if you replace that with, you get sine square a plus cos square a plus 1 plus 2 cos a, right? So let's move to this one. So we can write that 1 plus 1 becomes 2, 2 plus 2 cos a. You can, if you take 2 as common, you get 2 into 1 plus cos a. See, 1 plus cos a term is a numerator and a denominator. What you can do with this? You can cancel it. So we get 2 by sine a. What is 2 by sine a, students? It is cosecant a. This is 2 cosecant a we are getting. So that is the RHS. Hence proved. See, we have solved the first proving question. Can we move to the next question? Let's go to the question number 2. So the question number 2, prove that cosecant a minus sine a into secant a minus cos a into secant square a equal to tan a. See, there are 3 terms and there are only 1 term. Okay, what do you think about this one? See here, tan a, what is tan a trigonometric ratio? We can say it is sine a divided by cos a, right? Maybe if I get this sine a divided by cos a, I can easily convert into tan a. So let's take the LHS. So we get here LHS cosecant a minus sine a into secant a minus cos a into secant square a. So if you take the cosecant a, what is the cosecant a in terms of sine? It is 1 by sine a. And secant 1 by cos a into secant square a, you write it. We can convert the secant square a into 1 by cos square a later, or you can multiply cos square a into secant square a. We can say it is 1. So now if you simplify this one, this is becoming 1 minus sine square a divided by sine a. And this term 1 minus cos square a divided by cos a into secant square a. So we get cos square a by sine a into sine square a by cos a into secant square a. Okay, so the next step you see, the cos square a into secant square a, you can make it 1, and sine square a and sine a you can cancel. So the end result we're getting sine a by cos a. What is sine a by cos a, students? It is tan a. Hence we get the RHS as proved. See, 2 questions we have solved just like that. Let's go to the next question. Question number 3. Question number 3, what is given? Cos a divided by 1 minus tan a plus sine a divided by 1 minus cot a is equal to cos a plus sine a. So we take it LHS, cos a divided by 1 minus tan a, sine a divided by 1 minus cot a. So tan a, how can you write it? Sine a by cos a. Cot a, you can write it cos a by sine a. Let's use that. See, we can see cos a minus sine a and sine a minus cos a are additive inverse to one another. So I can take minus common in the denominator. So let's do that one. Cos square a divided by cos a minus sine square a divided by cos a minus sine a. Now denominator is same, so we can subtract the numerator. So we get cos square a minus sine square a divided by cos a minus sine a. So now the cos square a minus sine square a, you can apply a square minus b square formula. So cos a plus sine a into cos a minus sine a. If you apply, cos a minus sine a got cancelled. So we are left out with cos a plus sine a, which is RHS. Hence proved, students. So we had just like that we solved question number 3. So you're able to understand now. See, we are using all the trigonometric ratios like cosecant, secant, and everything. So this is the type of memory you should cultivate, students. Once you know something, how to apply in different questions. So this is like practically applying the theory which you are learning. So very good chapter, right? Let's go to the next one, question number 4. So question number 4, prove that sine a divided by 1 plus cos a is equal to cosecant a minus cot a. See, left hand side cos and sine are only there. Right hand side cosecant and cot. Oh, then what you do? See, just this type of questions. Think about cosecant. How can you write cosecant? It can be written as 1 by sine a. And cot is like cos a by sine a, right? So if you see, the sine a is same in the denominator. You can take 1 minus cos a divided by sine a. Is 1 minus cos a is available in the left hand side? No, right? So this is the one way of thinking, students. How to cultivate this observation means by practice. As you experience a lot of questions, as you go through a lot of practicing all the questions, you will come to know, okay, I can apply this, I can apply this. You will be thinking like that. So now here 1 minus cos a is not there in the left hand side, right? So I'm going to multiply with 1 minus cos a, both numerator and denominator. Let's see what will happen. So sine a into 1 minus cos a divided by 1 plus cos a into 1 minus cos a. So it will convert into sine a into 1 minus cos a divided by 1 minus cos square a. 1 minus cos square a, you can replace it as sine square a. by using the first trigonometric identity. So we can get it 1 minus cos A divided by sin A, because sin and square get cancelled. So now we are getting 1 minus cos A divided by sin A. What is 1 minus cos A divided by sin A? You can write it as 1 by sin A and cos A by sin A, which is equal to cosecant A minus cot A. We got the RHS, students. That's it. Solve question number 4. I hope you felt very easy till now, right? Okay, we'll go to the question number 5. Prove that tan square theta divided by secant theta minus 1 whole square equal to 1 plus cos theta divided by 1 minus cos theta. Okay, left hand side, if you see tan square theta, secant theta are there. Right hand side, only cos is there. Okay, you can be thinking like, can I convert into tan into sine and cos, or secant into 1 by cos? Okay, you can do that. Let's see if tan square is there. Can we write in terms of secant theta? That we will see here. So we will take LHS, that is tan square theta divided by secant theta minus 1 whole square. See, tan square theta you can write using the trigonometric identity. Secant square theta minus 1, you can write it, right? Now secant square theta minus 1, you can write it as secant theta plus 1 into secant theta minus 1, you can write it. Yeah. Now you can see secant theta minus 1 is common both in numerator and denominator. So you can cancel it. So we get secant theta plus 1 divided by secant theta minus 1. So now secant theta, I want in terms of cos. Here we have in secant theta. If I replace secant theta with 1 by cos theta, yes, we will get that. Let's see. So we get 1 by cos theta plus 1 divided by 1 by cos theta minus 1. If you take the LCM, 1 plus cos theta by cos theta, 1 minus cos theta by cos theta. You can cancel cos theta, so you'll get 1 plus cos theta by 1 minus cos theta, which is equal to RHS. We have solved question number 5, students. I hope you are able to feel that it's very easy to solve any question, right? Let's go to question number 6. So question number 6, prove that tan A plus secant A minus 1 divided by tan A minus secant A plus 1 equal to 1 plus sin A divided by cos A. This is a very important question. So this question I'm going to do in a particular way, which I'm going to use the one I'll use as secant square A minus tan square A. So practice as many questions as possible, students. You can crack the boards, like you can get 100% in boards. If trigonometric questions you're able to solve very nicely. Let's go to the LHS. So LHS we get tan A plus secant A minus 1 divided by tan A minus secant A plus 1. So we get it tan A plus secant A minus the one I'm saying, right? I'm going to replace with secant square A minus tan square A. Now I'm going to write the first two terms secant A plus tan A. You can write A plus B is B plus A also. Now secant square A minus tan square A. I'm going to write it as secant square A minus tan square A equal to secant A plus tan A into secant A minus tan A. So now you can see the secant A plus tan A is here and here also. So I'm going to take that common. So why did I do this step? If you see the next step, secant A plus tan A, when you take it common, you got 1 as the term factor left here. And here we have secant A minus tan A with minus sign, right? So 1 minus secant A minus tan A, we got it. When you open the bracket, you can see the denominator and this term is same. So we can cancel that. So we will see in the next step. So we have secant A plus tan A into tan A minus secant A plus 1 divided by tan A minus secant A plus 1. So now you can cancel these two terms. We get secant A plus tan A. But the question is not about secant A and tan A. It's about sine and cos. So I'm going to replace secant A is 1 by cos A and tan A is sine A by cos A. So we get the final result 1 plus sine A divided by cos A. Okay, students, let's see. The question number 6 is done. So let's go to question number 7. Prove that sin A minus 2 sin cube A divided by 2 cos cube A minus cos A equal to tan A. I want to get sin A by cos A in the LHS. Can we get it or not? Let's do that one. See, take the LHS. If you take the LHS, how much are you going to get? Sin A minus 2 sin cube A divided by 2 cos cube A minus cos A, right? You can take sin A common in the numerator. You can take cos A common in the denominator. Let's take that one. Sin A into 1 minus 2 sin square A, cos A into 2 cos square A minus 1. See, already sin A by cos A is how much? Tan A, right? So that means there is some way you can make these two terms equal. Okay, so one is in cos square, another is in sin square. What do? I will convert the sin square in terms of cos square so that let's see whether they are equal or not. So we can see in the next step, tan A into 1 minus 2 into 1 minus cos square A divided by 2 cos square A minus 1. So if you open the bracket, you see you will get 2 cos square A minus 1 by 2 cos square A minus 1. So we can cancel both. So equal to tan A. So hence, fruit students, LHS equal to RHS. Question number 7 done. Let's go to the next last 3 questions. Let's do it. Question number 8. Prove that sin theta into tan theta divided by 1 minus cos theta equal to 1 plus secant theta. Okay. Let's see here. So sine theta into tan theta by 1 minus cos theta equal to 1 plus secant theta. Okay, students, without thinking anything, let's write the LHS. Sine theta into tan theta by 1 minus cos theta. Okay, let me convert tan theta into sine and cos. Let me see what will happen. Do it. So if we convert sine theta into sine theta by cos theta divided by 1 minus cos theta, right? So we can see here sine theta into sine theta by cos theta into 1 minus cos theta. Now sine and sine you can multiply, it becomes sine square theta divided by cos theta into 1 minus cos theta, right? So let's see, students, we get sine square theta by cos theta into 1 minus cos theta. Can we write sine square theta in terms of cos? Yeah. So I'm going to replace that with 1 minus cos square theta. So divide by cos theta into 1 minus cos theta. So now 1 minus cos square theta, you can write it as 1 plus cos theta into 1 minus cos theta. So you can cancel 1 minus cos theta both numerator and denominator. So we get 1 plus cos theta by cos theta. That is equal to 1 by cos theta plus cos theta by cos theta. You can say secant theta plus 1, right? So which is equal to 1 plus secant theta, which is equal to RHS, students. So we have solved the question number 8. Let's go to the next question, last one question. Question number 9. Prove that cosecant theta minus sine theta into secant theta minus cos theta into tan theta plus cot theta equal to 1. So there are 3 terms, but right hand side we get only 1. Let's see how to solve this one. I think in the previous questions we have solved cosecant theta minus sine theta and secant theta minus cos theta. We have wrote cosecant theta 1 by sine theta. Let's write LHS we have taken. 1 by sine theta minus sine theta. 1 by cos theta minus cos theta. Sine theta by cos theta plus cos theta by sine theta. So we can say 1 minus sine square theta by sine theta, 1 minus cos square theta by cos theta, sine square theta plus cos square theta by sine theta into cos theta. So let's go to the next step. See, we get 1 minus sine square theta, you can replace it cos square theta. 1 minus cos square theta, you can replace with sine square theta. So cos square theta by sine theta into sine square theta by cos theta into 1 by sine theta cos theta. I think sine square theta we can cancel it. You have the cos square theta, you can cancel it. So we're getting 1, which is equal to RHS. I hope you've done the 9 questions easily, right? Let's go to the next question. So prove that 1 plus tan square A plus 1 plus cot square A equal to 1 by sine square A minus sine power 4A. So take the LHS, 1 plus tan square A plus 1 plus cot square A. So convert into sine and cos. So we get 1 plus sine square A by cos square A plus 1 plus cos square A by sine square A. When you take the LCM, how much you're going to get? Cos square A plus sine square A by cos square A plus sine square A plus cos square A by sine square A. So what is the result of sine square A plus cos square A, students? So already you know, you can replace it 1. So we get 1 by cos square A plus 1 by sine square A. Now again, if you take the LCM, how much you're going to get? Sine square A plus cos square A divided by cos square A into sine square A. So which is equal to 1 by cos square A into sine square. Now see here, in the question, it's asked in terms of sine only. So now I'm replacing the cos square A with 1 minus sine square A. So when you replace with 1 minus sine square A, we get sine square A into 1 minus sine square A is equal to sine square A minus sine power 4A. LHS is equal to RHS, students. We have solved 10 proving questions. So I'm going to give you something for working. So you can solve this couple of questions. You can take a note. See, and I'll be sharing a PDF as a solution for these questions. I hope you like the session. And if you are able to solve all these proving questions, I can guarantee that you can solve any proving question in trigonometry. Okay, students, I hope you like this session. Please practice this. And I'll be sharing a PDF including these solutions of these questions as well. Please subscribe to our channel for more such videos. Thank you all.